So a lot of time when we look at triangles, we're looking at parts that are congruent, either side lengths that are the same or angle measures that are the same. But for this video, we're going to do something a little bit different. We're going to look at what happens when you have parts within triangles that are not congruent, that are not equal in measure. So we're going to be looking at some triangle inequalities. So let's start by looking at and thinking back to something we learned previously, which is a theorem that we learned that said that if two sides of a triangle are congruent, then what do we know, what other quality of that triangle do we know is true? So for instance, if I look at this triangle and I said that this blue side and this pink side were congruent, they were the same length, then what else would we know about this triangle? And you may remember that that would mean that we would know that these two angles down here would also be congruent. If these two sides are congruent, it makes it an isosceles triangle with this kind of turquoise side as the base of it. And we learned that when you have an isosceles triangle, the angles that are at the ends of the base are going to be congruent. All right, so if two sides of a triangle are congruent, then I'll go ahead and finish that. Then the angles opposite those sides, opposite them, are congruent. Okay, so we learned that. But now we're going to ask ourselves, well, what happens if two sides of a triangle are not congruent? What conclusions can we make? So for instance, what I'm looking at is, let's take that triangle, let's kind of copy it here for a second, but then let's take this pink side and let's either make it longer or shorter. Let's start off by making this pink side a little bit shorter. So what I'm going to do is I'm going to grab my eraser and I'm just going to chop off part of that triangle here. Okay, I'm going to make that a little bit shorter. Now, in order for this to keep being a triangle, obviously this turquoise side now has to pivot up this way. All right, it has to pivot up that way. It has to go from where it's at, it has to kind of swing up this way so that now it's right here. But in doing so, by making that side shorter, you'll notice that no longer are these angles going to be congruent. Over here they were. But we can see now that when we swing this turquoise side up to complete that triangle, this angle here got smaller, and what happened here is that angle actually got bigger from where it was. So obviously, if the two sides of a triangle are not congruent, we can kind of see intuitively that these angles that are across from them are no longer going to be congruent. They were congruent here when the blue and the pink sides were congruent, but when we shorten that pink side, they're not congruent anymore. Let's take a look real quick. Let's say that we decide that we want to make the, let's say we wanted to make that pink side longer. So in this case, we're going to take that pink side and we're actually going to extend it a little bit. We're going to make it a little bit longer. And now we can see that this, this turquoise side now has to swing down this way, and it has to get a little bit longer so that it's no longer where it's at currently. Let me get rid of it there. All right, it's no longer going to be there. Now that turquoise side is going to be kind of down this way. And we can see what happened here is that this angle, because that turquoise side swung down, it enlarged this angle. This angle got bigger. And this angle here actually got smaller. All right? So what conclusions can we make? Well, we can say, first of all, that obviously when the sides are not congruent, then the angles across from them will no longer be congruent. But can we say more than that? So once we shortened this pink side, right, now we have one side that's longer, the blue side, and one side that's shorter, the pink side. Well, what about these two angles? They're no longer congruent, but which one's bigger? The bigger one, let's go ahead and put a B, we'll put an L for larger and an S for smaller. Well, now this side here is smaller, and that angle there is smaller, and that angle there is larger. Once I shortened this side, this angle got smaller, this angle got larger. When I lengthened the pink side, then this angle got larger and this angle got smaller. So that's going to kind of lead us to our first new theorem for this video. And that first theorem says that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So as a kind of a diagram, here's what we have. If we have this triangle here, and the value of B is bigger than the value of A. So maybe this is a 5 and this is a 3, for example. This is bigger than that. Then the angle that's across from that side, so if we go across the middle of the triangle and we look at this angle, that angle has to be bigger than the angle that's across from this shorter side. All right? So if B is longer than A, then this angle down here is going to be bigger than this angle that's here across from where the A is. And that's theorem 5-9. And then we can also see that the converse of that would be true. So if two angles are not congruent, in other words, if I have two angles in a triangle and one's bigger than the other, in this case angle B is bigger than angle A, then the side that's across from the bigger angle, this side right here, across from this bigger angle, it has to be longer than the side that's across from this smaller angle. So in this case, if angle B is bigger than angle A, then the value of B right here, this length, has to be bigger than the value of A, this length. And that's the converse of the last theorem. So even though these are technically kind of two theorems separated, they really are conveying the same idea, that if I have a triangle with different sides or angles, then the bigger angle will be across from the bigger side, and the smaller angle will be across from the smaller side. Now the next thing I want to look at is I want you to think about, let's say I had these 4 segments. I had this segment here that's 10 units long, and then I had these other three segments that are 4, 5, and 6 units long apiece. If I wanted to build a triangle, starting with this black segment that's 10 units long, could I just pick any 2 other segments out of this group and build my triangle with it? In other words, does it matter which 2 segments I pick over here? Can I take those 2 segments, attach them to the ends of this 10 unit long segment, and make a triangle out of it? So let's think about that for a second. Let's say I wanted to use this segment and this segment, the one that's 4 units long and the one that's 5 units long. Now you might think, oh yeah, as long as you have 3 segments, you can build a triangle out of those. But let's imagine we take this segment and we bring it over here and we kind of attach it to the segment that's 10 units long. So what I'm going to do real quick is I'm going to just kind of pull out a copy of that segment just so we can visualize. So we're going to take that segment, we're going to put it down here on this end, and then we're going to take that 5 unit long segment and we're going to put it on this end of our 10 unit long segment. Now obviously when they're like this, they're not making a triangle, right? We need to take this and we need to kind of tilt it down this way, we need to tilt it down this way, and we need to tilt them until they touch somewhere in here to form a triangle. But if we look at this, if we think about what the range of this segment is as I move it, obviously it can kind of swing this way, but we don't want it to do that because then it's not getting any closer to forming a triangle. We're going to want to swing that segment more in this direction, right? But it can only go so far. If I swing it all the way down to here, all right? And then as I get closer and closer to that 10 unit long segment, the black one, well, I can't be right on top of it, right? I can't be right here on top of it because then I wouldn't be making a triangle when I connect it to the other side. So I could swing that segment anywhere along this kind of arc that I've represented here in yellow. Same way I can do with this, I can do the same thing with this one, right? I can swing that anywhere along, let me get that yellow color. I can swing that one anywhere along this kind of arc. But what we'll notice is that we're going to have a problem because no matter where I put that pink segment, anywhere along that arc, I'm never going to be able to get the pink segment to match up to the blue segment, right? I'm going to have a bit of an issue. Now, what if I say, okay, I don't want to use the pink segment. I want to come over here and I want to use this guy. So let's go ahead and grab him, the 6 unit long segment. And let's pull him over. We're going to attach him right there. Now, what we see is that now we can swing that that green or that turquoise segment anywhere along this arc. So we can have it there, we can have it there, right? And it can swing anywhere along that arc. And it looks like, okay, I think I'm going to be good. I'm going to be able to match the blue segment up with that teal segment, except for what I realize is that the only way that they're going to match up, because one's 4 units long and the other one's 6 units long, the only way the ends will ever be able to touch is if I actually lay them down right on top of my black 10 unit long segment. And if I do that, I don't have my triangle anymore, right? I have basically a segment, which isn't a triangle. So what I would need to do, there is actually two of these that I could pick to make a triangle, but it's not going to be the blue and the pink one. It's not going to be the blue and the teal one. It's going to be the pink and the teal one. Because let me show you. Let me kind of recopy my 10 unit long segment down here, right? This is 10 units long. Now if I take this pink one, attach him right there, and I take this teal one, and I attach him right there, and I think about, okay, well, where can these, what's the range of motion for these, right? The pink one can kind of swing anywhere like that, anywhere along that arc. The teal one can kind of swing anywhere along this arc. And there is this point right here where that range of motion from the teal segment and the range of motion for the pink segment, they kind of overlap right there, right? So if I take my pink segment and I attach it out there, and I take my teal segment and I swing it down to right there. Let me try and hit that mark a little bit better. Let me try and draw a straighter line. There we go. Now I have this side that's 6 units long. I have this side that's 5 units long. And then of course I have this side here that's 10 units long. And I have my triangle, right? With sides of 5, 6, and 10. So it wouldn't have worked using any other, the black segment and any other combination of two of these, except for using these two. And so the next thing I want you to think about is, well, why? What kind of rule could you perhaps come up with for what the three sides of a triangle have to look like if I'm actually going to be able to make a triangle out of those segments? What do the three segments have to look like? What kind of characteristics do they have to have if I'm ever going to actually be able to make a triangle out of them? And what should eventually kind of dawn on you is that the reason why, for instance, if I had the 10 unit long segment, the 4 unit long segment, and the 5 unit long segment, that was a no, right? That didn't work. And if I had the 10 unit long segment, the 4 unit long segment, and the 6 unit long segment, that was also a no. But if I had 10 and 5 and 6, this one worked. I didn't mean to put the extra S on the end there. Here we go. That one worked. Right? So what's the difference here? What is it that these two aren't doing that this one is doing? And the answer is here in our theorem 5-11, that if I want to make a triangle, the sum of the lengths of any two sides must be greater than the length of the third side. So for instance, if I look at this combination of side lengths, 10, 4, and 5, okay, if I add 10 and 4 together, obviously they're going to be bigger than 5. If I have 10 and 5 and I add those together, obviously that's bigger than 4. But the problem is here. If I add 4 and 5 together, that combination is not bigger than 10. And that's why we couldn't make a triangle out of it. Looking down here, 10 and 4, okay, that's bigger than 6. 6 and 10, okay, that's bigger than 4. But 4 and 6 is equal to 10, and it needs to be greater than the length of that third side. So 4 and 6 doesn't work, all right? But down here, 10 and 5, okay, that's bigger than 6. 6 and 10, yeah, that's going to be bigger than 5 when I add them together. And then last, 5 and 6 added together is going to make 11, which is still going to be bigger than the last side. So that's why this combination of side lengths worked. Now, if you're looking at this, what really, I kind of went through every combination of adding sides together. I added 10 and 5 and said, okay, 15 is bigger than 6. 10 and 6 makes 16, that's bigger than 5. 5 and 6 makes 11, that's bigger than 10. Really, all you would have to think about is, what if I take the smallest two sides and I add those together? Does it end up being longer than the longest side? Does that number end up being bigger than the length of the longest side? And that's really what you end up having to check here. 4 and 6 didn't work because it equals 10. 4 and 5 didn't work because it's not equal, it's smaller than 10. But 5 and 6 added together makes 11, which is bigger than 10, which is why this combination of side lengths worked for a triangle.